Hello, everyone. I welcome you all again to Scalar Academy's YouTube channel. And in this particular live session, we are going to properly understand about data science. So, data science right now is immensely popular across varied industries and also across the world. So, whether you're working in e commerce, healthcare, or whatever current industry you are, I am 100% sure that there would be some sort of requirement of data science over there. So, understanding this really huge importance of data science across varied industries, we shall properly understand what exactly is data science and also look at the data science life cycle in this particular live session. Now, before I start off, I do want you guys to give me a confirmation if you guys can hear me properly and see me properly. Let me also check that once on my mobile phone. Now, before I start off. So, seems like everything is proper over here. So, I will start off this session by asking a very simple question. What is data? Right? Now, when we talk about data science, you can basically divide data science into two components. One is data, and then you have science on top of it. But what exactly is data? So, whenever we talk about data, just look at different things around you. On a daily basis, what is it that you're doing? So, let's say you go to Amazon or Flipkart or whatever shopping site it is, and you make some online transaction. What are you doing over there? You are generating data. Similarly, let's say you have an Instagram account and you upload pictures onto your Instagram account. What are you doing over there? Again, what you're doing is generating data. Similarly, you have a Facebook account. Let's say you put up a post that could be a written post, it could be an image, it could be a video. So, what are you doing over there? You, again, my friend, are generating data. Similarly, we have a lot of these streaming sites. We have YouTube, we have Vimeo, and so on. And when you upload videos onto these different streaming sites, what you're basically doing is generating data. And especially right now, we are sitting on huge amount of raw data. Now, here you have to understand the difference between data and information. So, those folks who are watching right now, if you guys could let me know what is the difference between data and information, let me know. I'll wait for a bit. I'll just add that question over here. What is the difference between data and information? So let me just put that up in the chat for you folks. Now, if you guys have any idea of what is the basic difference between data and information, let me know. And it doesn't have to be perfect. Whatever you think is the difference, just put it up over here. So Vineet Khandelwal is saying data is raw. That's correct. Anyone else? Anyone has any opinion on what is the difference between data and information? Well, information is making sense of data. That's absolutely correct, Vineet. So whenever we look at data, so let's say if I give you a huge Excel sheet, and that Excel sheet probably has 10 million rows and probably 1 million columns. And if you are just looking at this huge Excel sheet, what you're looking at is raw data. So when you're just looking at raw data, you do not have any information from it. But let's say from this huge Excel sheet, which has 10 million rows and 1 million columns, when you try to find out simple information. So let's say from this huge Excel sheet, if you're trying to find out maybe, and if this Excel sheet is pertaining to college students, and you're trying to find out, which student has scored how many marks in the mathematics exam year on year. So what you're trying to do is finding out information from this raw data. And this basically is the entire point of data science. So let's come to the main part. Let me write down the main question over here, which is basically what is data science? So simply put, you have raw data all around you, and that data is coming from a lot of sources, and that data is present also in a lot of formats. Now, if you'd have to make sense out of those raw data, or if you'd have to find out some business insights out of that raw data, what you can do is you can apply some data science techniques on top of it. So you have a lot of data science techniques, and those data science techniques, basically we call them as ML algorithms, and you apply these ML algorithms and you find out beautiful information from that raw data. So this basically is the essence of data science. So I hope you guys are clear on what exactly is data and what exactly is information. So now that we understand what is the difference between data and information, and also we understand what exactly is data science, we shall look at the life cycle of data science. So let me put up the next topic over here. Let me just write it down as life cycle of data science. So whenever we talk about the life cycle of data science, the first stage in any life cycle is acquiring data. So let me just show that to you over here. So the first step in the data science life cycle is to collect data. Now, let's say you have a client coming up to you with a problem statement. Now, that problem statement could be related to any domain. It could be a healthcare domain problem. It could be an e-commerce related problem. It could be probably a blockchain related problem. So what you're basically doing over there is, when you have the problem statement, your first step needs to be to collect data from all of the sources. So let's just take a simple example over here. Now, let's take an example of a food delivery app. So this is just a very new food delivery app, and the problem statement is such as this. So it wants to increase its customer base. So if it wants to increase its customer base, it has to understand how its customers are behaving, and also how can it increase its market share. So the first step and what the company has to do is collect all of that data and analyze that data. Now, this could be the data which is present of their own customers, or this could also be the data of their competitors. So let's just say we have this food delivery app. Let's just name it as, let's call it Food Delivery X. So we have a food delivery app, let's call it Food Delivery X, and it wants to increase its customer base. The first step needs to be collect data, and collect data from multiple sources, and not just its own customer data, but also understand how its customers, how its competitors are playing the field. And here you'd have to understand that this data is present in multiple formats. So either you can just have simple raw data, which is basically log files of all of the customers. That is something which you can have. Apart from that, you can have data in the form of images as well. Apart from that, you can have data in the form of videos as well. So right now, especially in the current digital age, and also where we have pandemic, almost everyone is online. So there, the first step needs to be, let's say if I am a data scientist at this particular food company, what I'd want to do is I'd want to collect all of this data, and probably I'd also go through some of the sites such as Twitter, Facebook, and LinkedIn, and I'd also want to see what are customers currently talking about my food delivery app. So this stage is very, very important in any data science lifecycle. Vineet Khandelwal is saying collect data, data wrangling, and then analysis, and then predict. So that is sort of right. Yes. So in the first step, what we are essentially doing is collecting the data. Now that we have collected the data, the problem with this is it is raw data. So we have collected the data from everywhere, but it's quite raw. The problem with this raw data is it will have a lot of missing values. It will have a lot of outliers. It will have a lot of anomalies. And if I give you a simple example, so let's say if we take that same Excel sheet, which has around 10 million records and 1 million columns. Now, in that huge Excel sheet, there might be cases where, let's say, some of the rows are empty. There might be cases where the column names are incorrect. There might be cases where some of the values are they totally do not make any sense. So these are outliers or anomalies or missing values. And once you collect this raw data, your next step needs to be to clean all of this data. And here what you're doing is you're converting this untidy data into tidy data. So it is as simple as that. So you have collected your data, you have cleaned your data. Now, after you do that, what you'd have to do next is basically you would have to manipulate your data. And when we say data manipulation, what you're basically doing is exploratory data analysis. So once you have your tidy data, on top of that tidy data, you sort of employ some data manipulation as well as data visualization techniques. So let me give you certain examples of data manipulation and data visualization. So whenever we talk about data manipulation, again, we have this huge Excel sheet which has millions of records. And out of this entire sheet, if I'd only want to look at, and this again is this would tell me about the different details of a particular college. So from this huge Excel sheet, if I'd want only those details where, let's say, all of the students have scored more than 90 marks in their maths exam. So I don't want records of only those students where the students have scored greater than 90 marks in their maths exam. What I can do is I can deploy some of these data manipulation or data wrangling techniques. And for this, I have different languages. I can either use something as simple as SQL. I can just use an Excel sheet probably. So all of this can be done in the Excel sheet too. I can do this with the help of Python. I can do this with the help of R. So I employ different data manipulation techniques, and I can find simple insights from this raw data. Now, apart from this, I also have something called as data visualization. So with data visualization, what I do is, so again, if I just show you this huge Excel sheet, which has all of these records, the problem is I wouldn't be able to understand anything by just looking at this huge Excel sheet. Right. So I just have this huge Excel sheet right in front of me. And if I'm just looking at this huge Excel sheet, I wouldn't be able to figure out anything. I wouldn't know where is the head of it. I wouldn't know where is the tail of it. So for me, the best option would be to sort of create simple graphs on top of this, or simple imagery on top of it. So on top of this huge Excel sheet, which has millions of records, what I can do is I can just create probably a bar chart or a pie chart or a histogram. And on the basis of that, I'll be able to understand simple insights. And also it has said, so a picture speaks more than 1,000 words, isn't it? So instead of just looking at the data, if someone actually shows me a beautiful picture of that data, I'll be able to understand much more from that. So I hope this is clear. So we collect the data. So when we collect the data, that data is quite raw. The next step would be to convert this raw data into tidy data. And we convert that raw data into tidy data. Next, what we have to do is we have to employ certain exploratory data analysis techniques. Over there, we have data manipulation and data visualization. After this, we head on to machine learning. So in machine learning, this is where we have certain intelligent algorithms. So for now, let's just call these as intelligent algorithms. And we shall be applying these intelligent algorithms on top of the tidy data which we have. And we will be applying these algorithms on the basis of the problem statement. So let's say if the problem statement is such that I do want to divide my customer base into different groups or different clusters. So what I'm doing is I'd have to group them, or I'd have to cluster them. So here I have an algorithm such as k-means, or I have other clustering algorithms as well. Similarly, let's say I'd want to probably determine by how much can I increase my market share in the next quarter. So let's say in this particular quarter, I have a revenue of around, let's just say around 10 crore rupees. I do want to predict by the next quarter how much revenue can I generate. So for this, I can use an algorithm such as linear regression or probably random forest regression. So on the basis of the problem statement, I shall use a particular machine learning algorithm. So once we apply an ML algorithm on top of our raw data, we shall get a result. But it is not necessary that the result which we get is 100% correct, right? So Let's say the target was to predict how much our company revenue will be in the next quarter, and I've built a linear regression algorithm for that. And this linear regression algorithm will give me some sort of result, and it's definitely not necessary that it will give me 100% result. And in most of the cases, or in general, it will not give you the 100% accurate result. So this is where what you'd have to do is you'd have to evaluate the algorithm, or you'd have to tweak the algorithm again and again. And this is where, so if you're working with Python or R, you have something called as hyperparameters. So you keep tuning or you keep updating these hyperparameters so that you get that perfect accuracy with respect to your machine learning algorithm. And once you get that perfect accuracy, that is when you can say that the result which you get is actually correct. And that is when you finally go ahead and show your result. And now, whenever you are talking about showing a result, you are probably showing it to your customer or to your client. And in most of the cases, your customer or your client would not be as technologically or technically savvy as you. So here, what you'd have to do is represent your result using really beautiful graphs or really beautiful dashboards. And you'd have to do it because data visualization is also a very important skill set of a data scientist. So you as a data scientist might be able to understand all of this technical jargon quite easily. But put yourself in your client's shoes or put yourself in your customer shoes who probably wouldn't even know the D or A of data science. So that is where if you create some beautiful dashboards, they'll be properly understand, they'll be able to interpret your result easily. And this is the entire data science lifecycle, my friends. I hope this is clear for you. So now that we understand this, so we have understood what exactly is data, we have understood what is data science, we have also looked at what is data science lifecycle. Next up, we shall look at certain applications of data science. So first application is obviously finance. So whenever we talk about finance and banking, so there are certain roles such as financial analyst. So you have financial analysts working in the banking sector or in the trading and stock market sector because you have a lot of fraudulent cases happening. And one of the simplest case over here in a bank to understand with respect to data science is to figure out if the person who takes a loan would be able to repay your loan or not. So, as a bank, you obviously will again have a large number of customers, probably in millions, and it is not feasible for you to give out a loan for every person who applies for it. So there you will check different factors. So probably you will check the age of the person, you'll probably check the gender of the person, you'll check the salary of the person, you'll check if there are any defaulting cases by this particular customer. You will again check in what area is he living. You will check what is his work experience. You will check probably if he has a house or not. So you will evaluate all of these, and these are what you call as your independent variables, or these are your factors. So you'll understand all of your factors, and understanding these factors, you shall probably decide whether to give this person a loan or not. And all of this can be automated by using simple data science algorithms. So here you can use simple binary classification algorithms. So you have different classification algorithms such as logistic regression, random forest, decision tree, and so on. So you can use these different classification algorithms, and what you can do is on the basis of all of these factors, you can probably create an automation app which would tell you to whether to give a loan to this person or not. Probably this algorithm could also give you a percentage of how much percentage of by how much this person can default. Right, so let's say if the default rate of this person is around 95%, which would mean that definitely or most definitely this person would default. On the other hand, let's say the default rate of this person is in low double digits, which could be 10% or 12%, then you might be more inclined to give this person a loan. So these sort of algorithms can be applied in the finance sector. So I'm just checking if there are any questions over here. So that was the finance sector. Next up, we also have the healthcare sector. So right now in this pandemic, people are trying to understand the spread of this particular disease. People are trying to understand when will the third wave come in India, or when will probably give out all of the doses properly. So all of this research can be done using data science. So I shall give you certain simple examples over here. So you do not need to be an expert in data science. If you just know some basics of data science, what you can do is you can probably understand how the coronavirus has spread across different states in India, or probably even across different countries. And all of this data would be available to you across free open source sites. You have sites such as Kaggle. So you can just go on to Kaggle and you will have multiple data sets related to the spread of coronavirus and so on. So what you can do is you can just go ahead and go through that data set, browse that data set, and you can find out simple insights on, let's say, from when the pandemic started and how many cases have been increased since the last 2 years when it actually had started. You can probably compare how the virus has spread by comparing different states. So you can probably compare a state such as Karnataka and compare it with probably Maharashtra, and understand how many new cases have come up, how many people have recovered, and so on. So these are different things which you can do in the healthcare sector as well. Then next comes marketing. So marketing is something where data science is used a lot, because marketing folks, they normally have targets to increase their market share, to bring more awareness to their particular brand. And here, data science plays a vital role in understanding the customer sentiments. So here a particular and a very interesting example of data science is known as sentiment analysis. So if you're actually able to gauge the sentiment of your customer, if you're able to gauge whether your customer's sentiment is positive or negative or neutral, then on the basis of that, you can probably tweak your product. So let's say there is a shoe manufacturing company, there's a shoe brand, and it launches a latest, new shoes over there. So what it can do is the data science folks in that particular company can just go on to Twitter, Facebook, or LinkedIn and probably understand what are different customers talking about their latest launch. And if it's positive, well, that's good for them. If it's negative, that is also good for them, because they can go back and tweak their product a bit. So here, using sentiment analysis, again, you can use different algorithms, use sentiment analysis, and have probably a score over there, right? So let's say if the score is between 0 and 1, and if it is above 0.5, you can probably say that the sentiment is positive. If it is 0, or if it is less than 0.5, you can probably say that the sentiment is negative. So all of these things can be done in the marketing side of things. Then we have entertainment. So the simplest example of how data science is used in entertainment could be all of your streaming services, and one of your best streaming services, Netflix. And Netflix has this really amazing recommendation engine. And how do you think this recommendation works? Well, the answer, my friends, is data science again. So what Netflix uses is something called as user-based collaborative filtering, where it is user-based collaborative filtering and item-based collaborative filtering, where, let's say, if you normally watch something related to sitcoms. Now, let's say if I watch this TV show Friends and I add it to my watch list, since it is a sitcom, since it is a comedy genre, Netflix will recommend similar sort of shows to me. Right? So this is a simple recommendation engine, which is an example of data science. So I hope this is clear to you, folks. So these are some applications of data science. So now that we've understood all of these basics, in today's particular session, what I'd want to do is I'd want to start off with one particular algorithm, which would actually be linear regression. So let me open up Jupyter Notebook over here. So I hope you guys can see this properly. So let me just write down a comment over here, linear regression, and I hope you guys can see this. And linear regression is a machine learning algorithm. Now, in machine learning algorithm, it can broadly be divided into 3 categories. So let me just write that down as well. So if we have machine learning, so you can probably divide it into supervised learning. You have something called as unsupervised learning, and you also have something called as reinforcement learning. So you have supervised learning, you have unsupervised learning, and you have reinforcement learning. Now, I'll give you a brief example of all these three different things. So let's start off with supervised learning. So let me write down supervised learning over here. And when it comes to supervised learning, what you can possibly understand over here is, let's say you have data and that data is associated with labels. So to give you a simple example, so let's say I have this water bottle with me. Now I'll just not have this water bottle, but I'll also have a label. So I'll have a text which would say water bottle. Similarly, let's say if I have this phone with me, I'll not just have this phone, but I have a text which will say that this is a phone. And this is the basic idea behind supervised learning, where you're dealing with data which has labels. And here you have something called as an independent variable and a dependent variable. So you have two things. I shall write that down. You have something called as dependent variable, and you have something called as an independent variable. And you normally try to understand how does the dependent variable change with respect to independent variable. So you can probably denote this dependent variable with y, and you can denote this independent variable with x. And what you're basically trying to find out is y as a function of x. So when you say y as a function of x, y is your dependent variable, x is your independent variable, and we are trying to understand how does y change with respect to x. And this is your simple underlying philosophy of supervised learning. And here both your x and y, you have data and you also have labels over there. So to give you a very simple example over here, let's say I do want to determine probably. So let's say if someone passes the exam, I'd want to understand what is the probability of a student for them to be a girl student or for them to be a boy student. And I'm giving a very, very simple example over here, right? So here my y is, let's say, girl slash boy. My x is pass slash fail. So let's say it just so happens that my data is quite skewed. I have 10 students in the class and there is a particular subject. And in that particular subject, it just has happened that out of the 10 students, we have, out of the 10 students, we probably have 5 girls and 5 boys. And all of the 5 girls have passed the exam and all of the 5 boys have failed the exam. And if I take this very data and if I feed it to this particular algorithm, so let's say if a new student comes in and if that new student is a girl, then probably the result, this algorithm will predict that the new student will pass the exam. On the other hand, let's say if a new student joins and if that new student is actually a boy, now even though, so that student is really brilliant, and in reality, that student might actually pass the exam, but due to my skewed data, this algorithm will predict that the student will fail the exam. So this is how, or this is the basic idea between supervised learning. And also in supervised learning, we have something called as classification and regression. So supervised learning can be further subdivided into something called as classification. Then you have something called as regression. And in this particular live session, we'll only focus on one thing, which is linear regression. Let me write that down properly. And before I move forward into linear regression, let me see if you guys have any questions. So Sandeep says, hello, everyone. Hello, Sandeep. I hope you are doing well too. So when we talk about linear regression, just take the simple formula over here. I shall just write down y is equal to mx plus c. So when I write down y is equal to mx plus c, what is happening over here is, here again, since linear regression is a supervised learning algorithm, here y would be my dependent variable, x would be my independent variable, and I'm trying to understand how does y change with respect to x. And here, this is the equation of a linear line. So, probably you would have learned about this in your 8th or 9th standard. You would have learned about linear equation of a line. And this is how the linear equation of a line looks like. So this is your dependent variable and this is your independent variable. And it's not necessary that you can only have one independent variable. You can have multiple independent variables as well. So when I say you will have multiple independent variables, this is how your equation shall look like. So here I shall write down y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So here y is a dependent variable, and this dependent variable is probably dependent on your multiple factors, which are x1, x2, and x3. And this is the basic idea behind linear regression algorithm. So once we've understood this, what we shall do is I shall open up our studio and we shall look at a simple example of linear regression. And before we do that, we shall also do a bit of data pre-processing as well. So let me just open up our studio for you guys. So this is our studio. So if you never used our studio before, let me just give you a glimpse of it. This, what you see, my friends, is known as the script window. This is where probably, let's say if you'd want to write a huge script, this is where you shall write your entire script. This is your console window. This is where you'll be executing all of your commands. So let me just write a simple command over here, 3 plus 7. You shall see that I have successfully executed this. Then you have this environment window over here. Here you shall probably have all of the commands which you have done so far. So I have this history command, and these are all of the commands which I have executed so far. Then here you have if you'd want to install some library. So you can just click on install over here, given the name of the library. So there would be certain libraries such as deployer. You have a library called as ggplot2. You have different libraries. You can just click on that and click on install, and all of these libraries would be installed. Now, in this particular session, we shall probably focus on both R and Python, and both of these are really important languages when it comes to implementing any of the data science tasks. And the specialty of R is it is a language which is developed by statisticians for statisticians. So if you are dealing with any statistical problem, however complex it is, then R is your best friend. It is your best tool to go with. And if you want to do probably any visualization, then R again is a really good tool for that. So there is a particular library in R called as Shiny R, and with the help of Shiny R, you can create beautiful dashboards straight out of this. So this is a simple example of our studio for you guys. And now that we know this, what I'd want to do is I'd want to give you guys certain basic idea of what we can do over here. So let's look at certain basic things. So if you want to do any operations over here, you can just do those. So let's say if I want to add two numbers, I'll just write down 12 plus 23. I can just execute that over here. And then we have simple variables. I can just go ahead and create a variable. So I'll have variable a is equal to 10, and I'll have another variable b, and inside this I shall store 20. So here you have seen that I've just created these two variables. Again, I shall write down a plus b. You will have 30 over here. So these are some basic operations which I can perform. And now, since the topic for today is data science, let me actually open up a data set and perform some, data manipulation and data science techniques on that. So by default, we have this data set called as Iris, which is stored in our studio. So let me just open that up. Here I shall write down view of Iris. So this, with the help of this view command, I can look at a data set. So this is the data set which I have. This is inbuilt in your R Studio. Now, if I want information about this, what I can do is I can just give a question mark over here, and I shall write down Iris. And you would see that in this help window, I have information about this entire Iris data set. So Edgar Anderson's Iris data And this famous Fisher's or Anderson's iris data gives the measurements in centimeters of the variables, sepal length and width, petal length and width. So you basically have this iris flower over here, and this iris flower has three different species. So these three different species are Setosa, versicolor, and virginica. And for those three different species, you have details about sepal length, sepal width, petal length, and petal width. And this is one of the most basic databases or data sets that you shall work with when you are beginning out as a data science enthusiast. Deceit Gaming is asking, do I really need to learn R to master in data science? So when you say mastering about data science, it has different pillars. And learning R language is just one of that pillar. So I'll just give you in brief about what are those different pillars. So first is obviously statistics and math. And as a data scientist or as a data science enthusiast or as a data science beginner, what many people find it difficult is get started with the maths of it or the statistics side of it. But it is extremely important that you do not ignore the statistics components of data science, because that is the building block of data science. So if you're good with the statistics fundamentals, if you're good with the math fundamentals, that would form the foundational stone for you to further learn other important or other complex topics in data science. So first step is master probably the statistics fundamentals, the math fundamentals. After that, what you can do is you can probably start with basic steps such as data manipulation and data visualization. Then going ahead, you would have to, now when I say master data manipulation and data visualization, again, you would need certain tools for that. So data manipulation, probably as a beginner, you'll start off with SQL. After that, you can pick up languages such as Python and R. So one thing which I'd like to tell you folks is both of these languages are quite similar. So if you know Python, then you can easily pick up R. Similarly, if you know R, you can easily pick up Python. So both of these are dynamically typed languages. Both of these are object-oriented programming languages, and both of these have sort of a similar syntax to work with. And if let's say if you know Python, then it is sort of quite easy for you to pick up R as well. So pick up R and start implementing these tasks. So first pillar is statistics or math. Next pillar is your programming language. Next pillar is obviously your ML algorithms. So it's not just necessary for you to directly implement all of these ML algorithms by the libraries which you're using. Also try to understand the underlying concept behind all of these ML algorithms. So that would be quite helpful for you. So I hope that answers your question. Aniket is asking, can one become a good data science learner beginning with Python? So when you ask, can anyone become a good data science learner beginning with Python, the answer would be yes and no. As I've said, Python is again only one component. So if you are good with Python, now it opens up a lot of doors for you. So here you'd have to decide what you would actually want to do with Python, right? Because if you only know Python, then probably you'd have to choose, if you can create web applications with Python, you can create gaming applications with Python, you can probably become a full stack developer, you can probably become a backend developer, you can create games, or if you actually want to venture into the field of machine learning, then you look at also other pillars of data science. So start learning the ML concepts, start learning the stats concepts, and start implementing them with Python. So if you ask, is Python enough to become a data scientist? I'd say no. And if you're asking, is Python important to become a good data scientist? Then I'll say yes. So it is one of the pillars necessary to become a good data scientist, and it is not the only pillar. So I hope that answers your question, Aniket. Great. So now that we have looked at this particular data set, what I'd want to do is I'd want to do certain basic manipulation on top of this data. So to perform data manipulation, I have this library called as deployer. So to open any library over here, I shall just use library. Inside this, I shall pass in the name of the library, which is deployer over here. I have loaded this. So now that I have loaded this, what I'd want to do is, so let's say from this entire data set, I'd want to extract only those records where the sepal length is greater than 5. I shall write something like this. So here I shall write iris filter, and here I shall give in the condition sepal length is greater than 5, and I shall go ahead and store it in a new object. I shall call that object as iris SL. Now let me have a glance at iris SL, view of iris SL, and if you look at the sepal length column of iris SL, you shall see that all of the values over here are greater than 5. Right, so what I've done is a basic data manipulation, and I've been able to do this by just using one particular line. And this filter method, which you see, is part of the deployer library. So if you do want to work with this filter method, you'd have to load the deployer library first. And what I've done is from the iris dataset, or on top of the iris dataset, I have applied this filtering operation, and I've filtered out all of those records where the sepal length is greater than 5, and I stored it in this iris underscore SL. So I hope this is clear to you guys. Now, similarly, let's say from this entire original iris data set, I do want to extract all of those records where, let's say, the petal length is greater than 2. I shall write a similar command over here. I shall write down iris. Let me put this down properly. I shall give in the filter command, and inside filter, I shall write. So I would want all of those records where petal length is greater than 2. So let me write down petal dot length is greater than 2. And I shall store this in a new object called as iris PL. And let me have a glance at this view of iris underscore PL. And if you look at this petal length column, you shall see that all of the values are greater than 2. And if you look at this 32 to 49 of 100 entries, which would mean that, so in total, this data set has 150 records. So out of those 150 records, I have 100 records where the value of petal length is greater than 2. Similarly, let's say, again, let me dive into this a bit deeper. So out of 150, I have 100 records where petal length is greater than 2. Similarly, let's say I want all of those records where petal length is greater than 3. So here I shall write down iris filter petal length is greater than 3. I shall store this in iris PL3, view of iris PL3, and this is what I get. So here it seems that I have 99 entries. So out of the 150 entries, I have 99 entries where the petal length is greater than 3. So this again is an interesting insight, which would mean that there is actually one record where the petal length value is between 2 and 3. So this is quite interesting, which you have over here. Ashish is asking, could you start Java also? Yes, we actually have a plan of starting a live session series or probably uploading videos on Java too. And that is something which we shall definitely do. And also this weekend, what we are doing is we are doing a marathon live session on C++. So our instructor, Satya Sai, he shall be doing a marathon live session on Saturday and Sunday. So if you do want to get expertise in C++, please do attend that live session. So we shall probably, make it live anytime soon, and you can join us this weekend. So now that we have understood about this, again, what I'd want to do is I'd want to make simple visualization on top of this. And to make visualization on top of any data, I have a library called as ggplot2. So let me actually install that library packages. I'll click on install, and let me give in the name of the library, which is equal to ggplot2. And probably this shall take a couple of seconds for the library to be installed. Right, so we have successfully installed this library. Now that we have installed this, let me go ahead and load this library. So to load any library, I just need to use library. Inside that, I shall write down ggplot2. And over here, what I'll do is, I'll start off by writing ggplot. And onto this, I need to map in the data for which I need to make a graph. And the data which I'm working with is iris. So data, iris. After this, I need to use this parameter called as aesthetic. So here aesthetic would mean the metrics onto which I map my variables. So here, let's say I'd want to understand the relationship between sepal length and petal length, and I'll map the sepal length onto the x-axis and petal length onto the y-axis. So here I shall write x is equal to sepal dot length and y is equal to petal dot length. So I'm building a scatter plot on top of this iris dataset where I'm mapping sepal length, this particular column, onto the x-axis, petal length, this particular column, onto the y-axis. And since I have to make a scatter plot, so to make a scatter plot using ggplot2, I have this command called as geom. This would be actually point. So let me just select geom point over here and let me run this. And this, what you see is the scatter plot result between sepal length and petal length. So hopefully you guys can see this properly. So on the x-axis, we have sepal length. On the y-axis, we have petal length. And as you see, the sepal length value increases, the petal length value also increases. So you can sort of see there is a linear relationship between the sepal length and petal length. So also this is a positive linear relationship. So as and when the sepal length value increases, the petal length value also increases. So let me just go ahead and close this out over here. Now, if I'd want to add certain color onto this, what I shall do is I'll take this same command and inside this, I want the color to be determined by the species column. So I have the species column and I'm mapping the species column onto the call aesthetic over here. Now, when I run this, you would see that I have three different colors over here. And now when you see, so I have three different colors. I have these pink colored dots, and these pink colored dots show all of those records where the species is Setosa. I have these green colored dots, and all of these green colored dots are records where the species is versicolor. And similarly, I have all of these blue colored dots, and these determine where the species is virginica. So I have created a simple scatter plot, and also we can make some simple inferences over here. So out of these three species of iris flower, I can clearly say that the lowest petal length and the lowest sepal length would be of the Setosa species. And the maximum petal length and the maximum sepal length would be of the Virginica species. So these are the sort of simple inferences which you can make from this. Let me also again close this up over here. So these are basic things which you can create. Again, let's say if I want to make a simple histogram for any of these columns, that is something which can also be done over here. So what I shall do now is probably create a histogram for this sepal length column. Let me clear this. Again, I shall use ggplot onto the data aesthetic. I shall again use iris. Now after this, I shall have aesthetic, and I shall have only one attribute over here. So normally whenever we are making histogram, we use histogram for univariate analysis. And when I say univariate analysis, we are basically observing one observation at a time or one variable at a time. So here onto the x-axis, I map sepal length. Let me write down sepal dot length over here. And what I'd want to do is I map sepal length and I'd want to make a histogram. So let me just write down geom histogram over here. And I've successfully created this histogram. Now let me also add certain color to this. So here I shall use a fill color. I shall write down fill is equal to pale green 4. And I shall also give a boundary color over here. I shall write call is equal to green. And let me zoom this up, and this is what you shall get. So I've created a simple histogram for the sepal length column. And over here, what you can probably understand is, let's say, so majority of these observations over here. So this, what you see is the sepal length value, and this, what you see is the number of records over here. So I have probably around 11 records. So I have 11 records where the sepal length is around 6.5. Similarly, I have very few records. Probably I'll have one record over here where the sepal length is almost equal to 8. Similarly, I shall have only one record over here where the sepal length is probably around 7.1 or 7.2. So this is exactly this 10 mark over here. So I shall probably have around 10 records where the sepal length would be between 4.8 to 5. So again, all of these interesting metrics can be found out by using this histogram. So hopefully this is clear as well. Now what I'd want to do is I'd quickly want to create a linear regression algorithm for this. And since today's topic is introduction to data science, and I've also said that we'll be covering one particular algorithm, what I'd want to do is I'd want to build a linear regression algorithm on this particular data. And since linear regression, I would need a dependent variable and I'd want independent variable. So here I'd want to determine, again, how does sepal length vary with respect to petal length. So here sepal length would be my dependent variable, petal length would be my independent variable. So to create a linear regression model, I have this method called as LM. And in LM, I'll just write down, let me write down sepal dot length over here. I'll give in this tilde symbol. And here I shall write down petal dot length. And here I shall write data is equal to iris. So I'm creating a linear regression algorithm here. What this basically means is this is a linear regression algorithm where my dependent variable is sepal length and my independent variable is petal length. So whatever you give on the left side of the tilde symbol, that would be your dependent variable. And whatever you give on the right side of the tilde symbol, that would be your independent variable. So this is the formula. After you give your formula, you'd have to give in the data from which this formula comes in. So sepal length and petal length obviously belong to the iris data set. And I'm creating this linear regression model over here, and I shall go ahead and probably store this in a new object, and I shall call this as linmod1. I've created my basic linear regression model. Now let me actually go ahead and predict the values. So to predict the values, I shall use predict. This takes in two parameters. First parameter is the model which you built. So the model which I've built is linmod1, and obviously test data is again the data which I'm using. So here I shall write new data, and new data again is iris over here, and this I shall go ahead and store it in a new object and call it as lin result1. So let me show you lin result1, view of lin result1, and this is what I have over here. So I have certain values. Now what I'd want to do is I'd want to find out the error in prediction. So if I'd want to find out the error in prediction, what I can just do is find out root mean square error. So this might be a bit complicated for you guys, but just bear with me right now. So probably in the future sessions, you shall probably understand what exactly is root mean square error and why are we doing this. So right now we have predicted something, but it's not necessary that the value which we get is actually correct. So what I shall do right now is I shall create a new data set, and what I'd want to do is I shall use cbind over here. With the help of cbind, I can combine different columns. So from the iris data set, since my dependent variable is sepal length, I shall take sepal length, and I shall take lin result1, which are the predicted values. And since this is actual, I shall call this as actual. Since this is predicted, I shall call this as predicted over here. And I shall store this in a new object and call this as new iris. Now let me have a glance at new iris. So new iris, what I have are my actual values and the predicted values. So folks, we have just built our linear regression algorithm. These were the actual values which were present in the data set. And what we've done right now is using the linear regression algorithm, we have also predicted these values. So very simple application of how you can do it using our language. So folks, I hope this is clear as well. And I believe we're also done with today's time. Hopefully this was quite informative to you folks. So also just a quick information, today at 9 o'clock, we have another live session taken by Mohit Yadav. And he shall be taking a live session on system design, and it will be a live mock interview on system design. So all of the folks who are interested, please do join us at 9 o'clock. And also, if you haven't yet subscribed to our channel, please do subscribe to our channel, and also do not forget to like this video. So thank you very much, folks, and let's meet in the next one.